Now this is a differential amplifier, and those of you who are not familiar with op-amp in this configuration, this circuit is basically going to amplify the voltage difference between the inverting and non-inverting inputs right here. Pretty simple stuff. The question here is, in order that V out equals to K times the potential difference, actually that the two input sources V1 and V2, where K is a constant, find the relationship between the resistors. What is the relationship between these resistors right here? Okay. All right, let's try to do this. There's a little bit of math and derivation involved here, but we'll try to go slowly and try to understand this part. The very first thing we need to do, we need to understand here that Vin is ideally going to be 0, and it's actually a potential difference that of the Vp, the voltage at the positive terminal, and the negative terminal of the op-amp. So Vp minus Vn, and since Vn is going to be 0 ideally, which means Vp, if I put Vn equals to 0 here, then Vp become equals to Vn. One of the first goals would be to identify or determine Vp or Vn. Now Vp is easy to find out because I can just apply voltage divider here and find out Vp. So Vp becomes V2 times R2. Whatever the voltage is here, same voltage will be at Vp. So V2 times R2 divided by the total resistance, which is going to be sum of R1 plus R2. R1 plus R2. Okay. Now we're going to look at this part of the circuit, and we're going to apply KCL, right? KCL here. Now the current that's entering this node is basically V1 minus Vn over R3. V1 minus Vn over R3. And the KCL states current entering the node equals current leaving the node. So what is the current that's leaving across this R4? It's actually a potential difference of Vn minus V out. So here you have Vn, and here you have V out. So Vn minus V out over R4. Vn minus V out over R4. Now, just to correct a few things, this is going to be V2. This is actually, I just looked at the problem. This is V2 and this is V1 right here. So V2 here, V1 here, which means this right here will be V1, not V2. Okay, all right. And which will also mean this will be V2, not Vn. So V2 minus Vn, and hence we have this. Okay, now I can rewrite this equation as V2 over R3 minus Vn over R3 equals to Vn over R4 minus V out over R4, correct? Now if I rearrange this equation such that I am interested in finding V out, this equation then becomes Vn 1 plus R4 over R3 minus V2 R4 over R3. Basically, if I take R4 as a common and then take it to the other side of the equation, this R4 will be multiplied by these two terms, and then taking Vn on left hand side as well, the equation will become this right here. Now remember, your V out equals to Vn times this minus V2 R4 over R3. Vn is here already. We have determine equation for Vp, since Vp equals to Vn, I can substitute this Vn with V1 R2 over R1 plus R2, correct? So that's what I'm going to do now. The equation then becomes V out equals to V1 R2 over R1 plus R2, correct? And then I'll rewrite the equation as it is. Rest of the equation, 1 plus R4 over R3 minus V2 R4 over R3. Now remember, we have this convention right here for V out, which is K, which is a constant, and then V minus V1 minus V2. And notice here, this part in this equation, this part here basically represents, sort of K over here. So if I put this part of the equation in, in this format, then I basically have what? 1 plus R4 over R3, 1 plus R4 over R3, right? The convention that I have with V1 and V2, which would be R2 over R1 plus R2, correct? And then I have minus here, and if I want to take this to the other hand side, to the right hand side of the equation, this negative will become positive. So I have R4 over R3, R4 over R3. So remember, this is K, this is the coefficient with the V1, and this is coefficient with the V2. I just took the coefficient and left the V1 and V2 aside. Now notice here, I got all resistors here over R4, taking this part right here over here and then taking this part to the right. So this becomes, this flips R3 over R4 times 1 plus R4 over R3, and this will go here, so it becomes R1 plus R2 over R2, correct? Now if I multiply this part of the equation with this, then I would have R3 over R4 plus 1, correct? This R4 and R4 will cancel out, this R3 and R3 will cancel out, equals to, if I split this, R1 over R2, R1 over R2, and then R2 over R2 is going to be simply just 1. This one and this will cancel out. Hence, R3 over R4 will equal R1 and R2, which basically means the values for R3 and R1 could be same, and R4 and R2 could be same in this circuit right here. So that's the relationship between the resistors.